Hello, my peeps. This Algebra Nation video will cover workbook page 6 times 7. We'll do problem 8, part A.
Sets of compound inequalities. When we do compound inequalities, not only do we need to solve for x, but we're also going to need to graph it. We're going to have to graph our solution. So let's take a look at our first question. We've got answer A, or problem A. We have 2 minus 3x is greater than 15, or 3 plus 5x is greater than or equal to 18. So what we're going to end up with is x could be one of two things. Let's see what we've got. Whenever we're dealing with an or, you're usually going to end up with an answer that says x can be less than something or can be greater than some other value. Let's figure out what those are going to be. When we're doing these compound inequalities, you're solving for x just like you would a normal equation. But there's going to be one extra rule, and we'll get to that. So we see 2 minus 3x is greater than 14. Ignore that greater than. We're not going to deal with that right now. First thing we want to do is get x by itself. Okay, well, let's see. On the left, we have our term with x. We have a negative 3x. Is there anything added or subtracted to that term? There's a 2. Is that 2 positive or negative? Positive. How are we going to get rid of it? We're going to subtract. We're going to subtract. Whenever we do something to one side, try to do it to the other side of our equation. Same rules for compound inequalities as there were for regular equations. So 2 minus 2 cancels out, and we're left with negative 3x. 14 minus 2, what's 14 minus 2? 12. All right, let's bring down that greater than sign. Now what do we need to do? We have negative 3x is greater than 12. What's keeping x from being by itself? Negative 3, right? Negative 3 is being multiplied by x. I divide by negative 3. Whenever I do to one side, I got to do the other. Negative 3 divided by negative 3 cancel out, and we get x. 12 divided by negative 3. A positive divided by a negative. Are we going to get a positive or a negative? Positive over negative, we're always going to get a negative. What's 12 divided by 3? 4. You got it. Now, when we do this, you divide by a negative or you multiply by a negative, here's that extra step that you've got to deal with. We're having inequalities. We need to flip the direction of our inequalities. So having a greater divided by a negative, it now switches to be a less than. We get our value. X is less than negative 4. All right, are we done? Nope, we've still got our second piece of our compound inequality. We're going to follow the same rules that we did before, though. We're just trying to get x by itself. And if it ends up that we divide or multiply by negative, flip that inequality. So let's see what we've got. 3 plus 5x is greater than or equal to 18. Well, what's keeping this 5x from being by itself? 3. Is it positive or negative? It's positive, so let's subtract. Now, when I subtract 3 from both sides, do I need to flip my inequality? No, you only flip the inequality when you're multiplying or dividing by a negative. So the 3 minus 3 cancel out. We've got 5x is greater than or equal to, what's 18 minus 3? 18 minus 3 gives us 15. Now what? Divide, right? We're trying to get x by itself, so we're going to divide. We're going to divide each side by 5. 5 over 5 cancels out. We've got x by itself. 15 divided by 5, what do we get? 3. So, what's our solution? X can be less than negative 4, or it can be greater than or equal to positive 3. What does that look like on a number line? Well, let's...
I think that we should take a brain break. Whatever you do, if you do this on the EOC, you will not get a 399.
Challenging 5-game road trip with an encouraging for them 105-100 win against the Clippers today. Missed the dunk, and the rebound to Taylor. Yesterday and again this morning, and maybe some evidence, nobody did touch him. No, some evidence there that LeBron is not quite. Challenging 5-game road trip.
So sad. That will not get you a 399. Back to work.
Thanks. All right, I've got some negatives and some positive values, so I know I'm going to put 0 here. I have negative 1, negative 2, negative 3, negative 4, negative 5, and it keeps going all the way into those negative numbers. I've got 1, 2, 3, 4, 5, keeps on going into those positive values. So x can be less than negative 4. So where's negative 4 on my number line? Negative 4 is right here. Can x be negative 4? No, it has to be less than negative 4. Well, you have a less than or a greater than sign. It can't be that actual number. X can't actually equal negative 4. It has to be less than it. So we're going to put a circle, an open circle. If this was a less than or equal to sign, then x could be negative 4, so we would fill in that circle. It would be a solid circle. because these negatives are kind of tough, go to the extreme. All right, if we shade it into the area of the right, is 2 less than negative 4? 2 is bigger than negative 4. That's not right. What about negative 5? Is negative 5 less than negative 4? Yes, it is. We are shading to the left. We're going to draw our arrow to the left. X can be less than negative 4. It can't be equal to negative 4, but it can be less than negative 4. All right, let's see what we've got here. X can be greater than or equal to 3. Okay, can it be equal to 3? Yeah. Whenever you have a greater than or equal to or a less than or equal to, it can be that value. So we're going to have a solid circle at positive 3. Now, we're going to say that X can be any number greater than or equal to 3. Well, is 1 greater than or equal to 3? No, it's less than that. Is 5 greater than or equal to 3? Yeah. If it's greater than, we're shading above. And you guys, that's it. We just solved that compound inequality. We just have two different expressions, two different equations giving us possible values for X. We figured out, you know what? X could be less than negative 4, or it could be greater or equal to positive 3.